Page 467, lesson 7-8 is on geometric sequences. So, geometric sequence, basically what's happening here, the book says the ratio of any term to its preceding term is a constant value. What's happening in a geometric sequence is we're going to multiply by the same number each time to get the next term. So if we look at this, we've got a formula for a geometric sequence, and it's like our exponential function that we've been talking about, very similar to that. Notice the n and the 1 are down lower. Those are called subscripts, so that's a sub n and a sub 1. So we have a sub n equals a sub 1 times r to the n minus 1 for n is greater than or equal to 1. If you go back up a little bit above that, they tell us the starting value is a. That's like our initial value we've been using for exponential functions, so same idea there. And then the common ratio r is what they multiply by to get the next term. We really had a common ratio when we did exponential functions as well. It's just that we kind of talked about it differently. They said there was a 5% increase, so we did 100% plus 5%, and we got 1.05. But 1.05 was like our common ratio when we did exponentials. We just didn't call it that. We called it a growth factor. Now we're calling it a common ratio. With common ratio, it could be a number bigger than 1, would be when the numbers would be getting bigger. If it's a number less than 1, if the common ratio is less than 1, then our numbers will get smaller. So we're not going to have a separate thing where we talk about growth and decay here. We're just going to use the same formula, and whether it's bigger than 1 or less than 1, we'll just call it a common ratio either way. And then one other thing here, the book doesn't really define too much, I don't think, is what n is. So n is representing the term number. N is the term number. By term number, basically if we had numbers, let's say we had 5, 10, 15, 20. The term number just tells us what term it is in the sequence. So for the 5, that would be the first term. So that would be like n equals 1. 10 was our second term. That would be like n equals 2. 15 would be like n equals 3. And 20 would be like n equals 4. So it's just telling us in our geometric sequence, what number is that in the sequence. So if you look at problem 1, talks about identifying geometric sequences. They're just asking which of these are geometric sequences. So you can see in part A, every time they're multiplying by 10, if they're multiplying by the same number every time, that's a geometric sequence. So on A, that's geometric because they're multiplying by 10 every time. The common ratio would be 10 because they're multiplying by 10 every time, and so it is geometric. Part B, if you look at that, we're trying to multiply to get from one thing to the next. So we know 2 times 2 is 4. 4 times 2 is not 6. We would have to do 4 times 1.5. You could do 6 divided by 4 to figure out what number you're multiplying by there. The point is these are not the same. First they were multiplying by 2, and then they're multiplying by 1.5. You really don't even have to do the rest of this. If they're not all the same numbers they're multiplying by, we don't have a common ratio, and then it's not geometric. So this is not geometric. This is actually a thing, it's called an arithmetic sequence, because the deal is they're adding to every time. Okay, which we're not going to worry about that. We're just going to deal with geometric here, but just FYI, that actually is something else. It's called an arithmetic sequence rather than geometric. Arithmetic is if they're adding or subtracting the same number every time. Geometric, we're multiplying by the same number every time. And then part C, this is a little different, but the sign's just changing every time. So they're just multiplying by -1 every time. So our common ratio is -1, and so it is geometric. So if we look at the got it, doing the same thing here, part A, so we're trying to see, are they multiplying by the same number every time? So from 3 to 6, that'd be multiplying by 2. 6 times 2 is 12, and it works for the others as well. So that is geometric. And again, our common ratio is 2, if they ask that, common ratio of 2. Part B, this one we're going from 3 to 6 is times 2. So we need to be multiplying by 2 for everything. 6 times 2 is not 9, so it's not geometric. This actually would be another example of an arithmetic sequence. They're just adding 3 every time. Part C. So this one we've got fractions. The numerator is staying at 1, so basically if you can look at your denominators, we know to get from 3 to 9 we're multiplying by 3. If our numerator stays the same, we'll just put a 1 up there. So that would be 1/3 times 1/3 to get to 1/9. And then the question is, did we multiply by 1/3 to get 1/27? The answer is yes. Did we multiply by 1/3 to get 1/81? The answer is yes. So that one is geometric. Oh, and it did say, sorry, I missed the directions. It said, if it is not geometric, is it arithmetic? So on part B, we would say not geometric, but it is arithmetic. Because they are adding 3 every time. And then part D. So this we're trying to get from 4 to 7. That's not real nice. And you might think, well, I'm going to have this crazy decimal if I divide 7 by 4, but it's actually is 1.75, so we could just go that route, say it's times 1.75, but then if you do 7 times 1.75, 7 times 1.75 is 12.25. We were wanting it to be an 11, so this is not geometric. We could double check then, according to the directions, we should check if it's arithmetic. 4 plus 3 is 7. 7 plus 3 is not 11 though. 7 plus 3 would be 10, so that doesn't work. It's actually, there is a pattern here. This would be adding 4, this would be adding 5, this would be adding 6. But if it's not doing the same thing every time, it's still not going to be arithmetic. So it's not geometric or arithmetic, I guess we could say. Or you could just say neither would work. We'll look at the next part. It talks about finding a formula for a geometric sequence. And it mentions here the explicit formula is more convenient when finding the nth term. So we are just going to do the explicit formula. We're not going to worry about the recursive. We are just going to find the explicit formula. Explicit formula is listed here. This is the one that we already talked about earlier in the lesson. So if you look on problem 2, they want the explicit formula is all we're going to do for this sequence. So explicit formula, a sub 1, that's the first term in the sequence. So you can see in their sequence here, you can see 7 is the first term, so 7 goes in place of the a sub 1. R is the common ratio, it's what they're multiplying by, so we know 7 times 3 is 21, times 3, 21 times 3 is 63, and so on. So 3 is our common ratio, which is kind of like what we did for like a growth or decay factor earlier. And then the n minus 1 just stays there. So our final explicit formula we actually keep as a sub n equals 7 times 3 to the n minus 1. The nice thing about having this formula is then we could find any term in the sequence. So if they said like what's the 100th term in the sequence, we could just substitute 100 in place of n instead of having to keep multiplying by 3 and write all these numbers, 100 numbers out. We can actually just substitute that in. We'll talk more about that in a little bit. So the got it, again, we're not going to worry about recursive, but let's find the explicit formulas for these geometric sequences. So part A, if we start out with this, so our first term is 2. That goes in place of the a sub 1. The ratio, you can see we're multiplying by 2, so our ratio, common ratio is 2. So this technically could be our explicit formula. One thing a little bit different on this one, if you'll notice those bases are both the same. This doesn't usually happen, but if the bases are both the same, we could actually say let's multiply those bases. We can add the exponents together, and that would be the same as 2 to the n power. So we could simplify a little and say it's 2 to the n power, but either way would be okay for that. Then we'll look at part B. Same idea, so we're going to start with our formula. So our first term is 40. The ratio, this time you might say, well, they're dividing by 2. They are dividing by 2. Ratio has to be what we're multiplying by. So if you're dividing by 2, that's the same as multiplying by half, or 0.5. So you could say 1/2 is your common ratio, or if you want to, you can have a 0.5 there as well, 5/10. Either one of those would be fine. So look at problem 3. 2 managers at a clothing store created sequences to show the original price and the markdown prices of an item. Again, we're just going to look at the explicit formula for each sequence, and then what will the price of an item be after the 6th markdown. One thing to consider when we do this, we have our original price. The second term is actually the first time we mark this down then. So if we're finding the 6th markdown, that would actually be the 7th term in our sequence. So the first sequence, you can see it was $60, then 51, and so on. So if you do 51 divided by 60, you get 0.85. Okay. 0.85 is our common ratio then. So this would be our formula for this one. And then since we're finding the 6th markdown is the 7th term, we're putting a 7 in place of n. We work that out, and we get $22.63. If you were doing this, you can write this, but understand if you were typing that in your calculator, we know 7 minus 1 is 6. So you'd be putting to the 6th power would be an easier way of doing that. Otherwise, you have to do the exponent and then make sure 7 minus 1 is in your exponent, or you have 7 minus 1 in parentheses. So $22.63 for that store. For the other store, we have this going on. for this one actually is an arithmetic sequence instead of a geometric sequence. So arithmetic sequence, basically, we had $60 and we're subtracting $8 each time. So you could just keep finding the numbers, I guess, if you wanted to. But this is actually back in lesson 4.7. Lesson 4.7 talks about arithmetic sequences, if you want to look back at that. Anyway, so they worked that out and they got that would be $12 for that part. So if we look at the got it 3, again, we are just going to be looking for the explicit formulas here. And they want us to find the 8th term of the sequence as well. So there's 2 parts. One part is find the formula. After you found the formula, then we're going to find the 8th term. So on this one, our first term is 14. And if you divide these numbers out, if you divide 84 by 14 is 6, we can verify that with our next numbers, that we are multiplying by 6 every time. So a sub n equals 14 times 6 to the n minus 1 power would be our formula. And now we're going to find the 8th term. So finding the 8th term, technically what we do, we replace the n with an 8. On the left side of the formula, we don't do anything with that. This is just representing that this is the 8th term in our sequence. Okay, it's not an exponent. There's nothing we have to do there. It's just showing that that's the 8th term. So we know 8 minus 1 is 7, so if you want to rewrite it that way, you can. And then just, you can type that in your calculator to get that answer. So that would come out to be 3,919,104. And if we look at part B, you can see on part B these numbers are getting smaller. First term is 648. This one, they're dividing by 2, so it's the same as multiplying by a half or 0.5, whichever way you want to put that. So this could be our formula, first of all. And then again, they want us to find the 8th term. So the 8th term, we would end up doing that to the 7th power. So that works out to be 5.0625, or if you wanted to, as a mixed number, it would be 5 1/16. Problem 4 I'll mention, it's not going to be our main focus here, but it tells us we have a geometric sequence, initial value is 6, common ratio is 2. And it says write a function and then graph the function. So writing the function, that would be just like what we've been doing. They're using x instead of n here, but same idea. Or you could say y equals. And again, the only difference, otherwise they're using an x instead of an n. And then they're just finding some values. So they're putting in a 1. Actually, they're not. They're putting in a 2, 3, 4, and 5 in place of x and seeing what they get. And then this is what the graph would end up looking like. And again, we've graphed exponential functions before, so don't worry too much about this. You've already done it, but you could do this if you were asked to. We'll look at a few problems on the lesson check. First of all, they're asking if these are geometric sequences. If so, find the common ratio. So we're seeing if there's a pattern multiplying by the same thing each time. And for the first one, the answer would be yes. Common ratio would be 3 because they're multiplying by 3 each time. Number 2, these numbers are getting smaller. Might be easiest to look at with the first two numbers. Going from 20 to 50, that'd be dividing by 4. Dividing by 4 is the same as multiplying by 1/4 or multiplying by 0.25 if you want. You can check that with the other ones as well, and it will work for all of them. So that one is yes as well. Common ratio would be 1/4 or 25/100. That's supposed to be a decimal there, sorry. Number 3, if you try to get this to work for multiplying by something, that doesn't work. So the answer is no. And so we don't have a common ratio to find. This one actually would be arithmetic. They don't ask us for that, but this is arithmetic. They're subtracting 2 each time. The next part, we're going to look at the explicit formula for the geometric sequences. Let's look at number 5. So number 5, we're kind of going back and forth here. The signs are changing. So these are actually multiplying by -2 each time. So if we start with our formula, our first term is 4. We're multiplying by -2, so -2 would be our R value. The -2 needs to be in parentheses when you write that. And that would make a difference if you were actually finding a term. If you're putting that in your calculator as well, you need the -2 in parentheses because -2 is being raised to that power. If you don't put parentheses around it and you have an even power, then without parentheses, the calculator is just going to take a negative of whatever your number is. And finally, let's look at number 6. So on number 6, if you try and divide this out, so 108 divided by 162, you'll get 0.6 repeating. You might know 0.6 repeating is the same as 2/3. So we can try this with the other numbers as well, but it actually works out for all of these. They're multiplying by 2/3, so a sub n equals 162 times 2/3 to the n minus 1 would be our explicit formula for that problem. So this gives you an idea of how to work with geometric sequences. Have a good day.